Hey there, ready to unlock the secret to mastering line equations and crushing those graph problems? Well, we are about to break down the equation of a line, so you will never get stuck on these questions again. By the end of this video, you'll be able to write the equation of any line, understand slopes like they are second nature, and breeze through your SAT math section like a pro. First, let us try to understand the fundamentals of the xy plane. The xy plane consists of the x-axis, which is a horizontal line, and y-axis, which is a vertical line, and they intersect at a common point, which is the origin. Each point in the xy plane is represented by the x and y coordinates, where x coordinates tells us the distance of the point from y-axis, and the y coordinate tells us the distance of the point from x-axis. The xy plane is divided into four equal parts, which we call them quadrants. And by the quadrant, we can tell the sign of the coordinates. In the first quadrant, both x and y would be positive. In the second quadrant, x is negative and y is positive. In the third quadrant, both x and y are negative. And in the fourth quadrant, x is positive and y will be negative. All the points above the x-axis will have y positive, and all the points below the x-axis will have y negative. Similarly, on the right side, the x-coordinate would be positive, and on the left side, in the second and third quadrants, x-coordinate would be negative. Also, if any one of the coordinates is 0, that indicates that the point is on either x-axis or y-axis. All the points on y-axis will have x-coordinate 0. So we call it line x equal to 0. Similarly, on x-axis, all the points will have y-coordinate 0. So we could call the x-axis as the line y equal to 0.
When coordinates of 2 points present in the xy plane are given to us, we can calculate the distance between those 2 points by applying the formula square root of x2 minus x1 whole square plus y2 minus y1 whole square. Also, by doing the average of x coordinates and y coordinates, we can find the midpoint of those 2 points. These are the two fundamental formulas which we need to remember for coordinate geometry. Slope is the most important concept in coordinate geometry. Again, we need at least 2 points present on the line to calculate the slope. To find the value of the slope, we do y2 minus y1 over x2 minus x1. So we divide the difference of y coordinates over corresponding x coordinates. We also call slope as rise by run, and slope is constant for any 2 points present on the line. Not only x1, y1, x2, y2, there could be any 2 points present on the line. Slope must be same. For example, if there are 2 points negative 2 comma 5 and 3 comma negative 2 present on a line, to calculate the slope of that line, we do negative 2 minus 5, the difference of y coordinates, over the difference of x coordinates in the same order. So that's how we get the value of the slope. Now, all the time, we don't have to depend on the slope formula to find the value of the slope of a line. We could simply observe the orientation of the line by looking at the line from left to right. So we need to always look at the line from left to right. And if the line is ascending, traveling upwards, then the slope would be positive. If the line is going downwards, then the slope will be negative. So if the line is horizontal, it is not rising, the rise is 0. So the slope also will be 0. And if it is a vertical line traveling upwards, then the slope would be undefined. Also, you could check the quadrants to tell the nature of the slope. And do remember, you always have to look at from left to right. Just imagine you're standing here and look towards the right. Now, if there are two lines with slopes m1 and m2, and if the lines are parallel, the slopes would be equal. And if the lines are perpendicular, the product of the slopes would be -1, or we could also tell one slope would be negative reciprocal of the other slope. So please remember these points and apply whenever you come across a slope question in the ACT exam. A line equation describes a straight line on the xy plane. It allows us to find points on the line and solve problems related to lines. The most common form of a line equation is called the slope-intercept form, which is written as y equals mx plus c, where m is the slope of the line and c is the y-intercept, the point where the line crosses the y-axis. X and y represent the coordinates of points present on the line, which in turn would satisfy the equation. For example, if we have y equals negative 3x plus 12, so the slope is negative 3 and the y-intercept is 12. So generally, whenever a line equation is given to us, we could type the same equation in Desmos and get the graph, the intercepts, and also we can plot all points on the line. The line equation can also be written as an equation in two variables, ax plus by plus c equals 0. Here in this case, the slope would be negative of a over b, where a is the x coefficient and b is the y coefficient. To find the x-intercept, we make y 0, and to find the y-intercept, we make x equals 0. For example, if there is a line 4x minus 3y plus 12 equals 0, the slope would be negative of the x coefficient 4 over the y coefficient negative 3. So that would be 4 over 3. And for the x-intercept, we make y 0. Then the corresponding x coordinate is negative 3. Hence, negative 3 would be the x-intercept. Similarly, we make x 0 to find the y-intercept 4. To recap, when a line equation is given, we can calculate the intercepts and slope. The most commonly used form is y equal to mx plus c, and sometimes it can be also used in the coefficient form. If a point lies on the line, it must satisfy the line equation. Alternatively, we can also check the line in Desmos. Now, we are not given the line equation, but there are some points given on the line. For example, if you consider a line with the points 3, 12 and negative 7, 2. So these are the points given to us, 3, 12 and negative 7, 2. So we can plot those points in the Desmos table, and Desmos is going to give us the slope value and also the y-intercept present on the line. So that way, we don't have to solve anything. We can simply plot those points in the table and get the corresponding line equation. You can also click here for linear regression and get the line equation. So using Desmos will make our task very easy and also saves us time.